All right. So I didn't think I'd be doing one of these, at least not this soon in the semester, but I see a lot of you are struggling. And that's okay. It's okay to struggle. Many of you asking, coming in the later time, coming in the morning, even ask me questions, which I got limited time too. I know you guys got busy schedules, I know, but I got a busy schedule myself, but I do want to help you. I want to help you as best I can. So in this video, I'm going to work through all 10 homework problems from homework 3.1. Okay? And hopefully this will help you out. Today is actually the due date for this homework assignment. So yeah, I'm posting the key. I'm basically giving you the answers. If it's late, well, you can get your 75, right? You can get your 75 and feel good. I really care that you just learn how to do this, okay? Grades, whatever, don't care. I just care that you learn how to do this. So, sorry, I'm burping a little bit. I drank a full can of Dr. Pepper before this video, so I might be a little burping. Okay, so let's do homework 3.1 together. Now, these first 5 questions just ask to use substitution, so that's what we're going to do. Let's do our solutions in red. Yeah. So, number 1, I've got 2x minus y equals 4 and 8y minus x equals 3. Goal is to substitute, right, meaning solve for one variable. Pick x, pick y. It doesn't matter. I'll pick y, okay? Choose to solve for y. Why, Mr. Spake? Why choose y? Just because you want to. I don't know. Just because. Why not? Why not? Right? Some mathematicians might say, why not? Did you catch that? Why not? If you didn't catch that, don't worry. I'll tell you what that means later. But maybe you did. Maybe you did. Funny math joke. Okay. So let's do this. Oh, that 4's ugly. Hideous. Erase. All right. So let's solve for y. This is pretty easy. I'm going to add y to both sides and subtract 4 from both sides, getting me 2x minus 4 equals y. Okay? So now that I have solved for y, I'm going to substitute this expression. So let's highlight that. This expression. I'm going to substitute that here into 8y. So now 8y minus x equals 3. So I'm going to replace 8y with 8 times 2x minus 4. Then minus x equals 3. Let's distribute that. 8 times 2x is 16x. 8 times negative 4 is negative 32. Minus x equals 3. I'll do some algebra 1 here. 16x minus x is 15x. And I'm going to add 32 to the other side, getting me 35. I will now divide both sides by 35. I get x equals, but divide both sides by 15. I'll get x equals 35 over 15. If you divide by 7 over 7, right? Say divide by 7 over 7. Then you get x equals 5 over, silly Mr. Spake. 5 over 5, not 7 over 7. You dummy. Sorry. I'm kind of sniffing. I got allergies. I apologize for my sniffles. 35 divided by 5 is 7. And 15 divided by 5 is 3. So you get x equals 7/3. Yay, hooray. Now, what does y equal, right? What the heck does y equal? Well, y equals this. So, we're going to take x equals 7/3 and say y equals 2x minus 4. This comes from here. So y equals 2 times 7/3 minus 4. That is 14/3 minus 4. And 4 is 12/3. So y equals 2/3. Done. All right, so x equals 1/3, y equals 2/3. Or x equals 7/3, y equals 2/3. So my final answer is 7/3, comma, 2/3. Box my answer. Call it a day. And that's it. Sorry, sniffles. Silly me. Pretty basic, pretty simple. If you're struggling with that first one, that means your Algebra 1 skills need serious refinement. Okay? I'm going to be handing my Algebra 1 students this year that problem. So if that's a struggle, you need to really go review that. I think I might post some IXLs on how to review this stuff at the really basic level. But that's about as simple as it gets in Algebra 2. Okay? Shouldn't be doing too bad on that one. By the way, please, 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 please. I'm going to say this now. Let's do this in purple. You see the 7/3? Please, for the love of all that is holy, stop writing this as 2 1/3. Okay? Stop it. Okay? We don't do that anymore. We just don't. I don't really know where this practice came from of writing mixed fractions with your math. I would cease that now. From Algebra 2 and henceforth, stop writing mixed fractions. Write them as improper fractions. Write them as one number divided by another number. None of this mixed fraction stuff. It's just too confusing, okay? And I don't mean too confusing for me. I mean it's too confusing for you. You're going to mess up your math. I've already seen it. A bunch of you are messing up your math because you're dealing with mixed fractions and you're just making it harder on yourself, all right? Just get used to improper fractions. You'll get used to it. It'll be fine. Okay, let's do number 2. I need to solve for R and Q using substitution. Notice, so I'll use my little laser pointer here. Woo! Whoa, 20. Isn't that supposed to say 20R, Mr. Spake? 20R? Yes. Okay, so, no, it's not. It's just supposed to say 20, isn't it? Actually, you know what? I need to go look. Hold on. This only took me a second. I need to verify that this is indeed the problem. I'm running to my laptop. I need to scroll up. Okay. It is. We're good. No worries. I'm heading back to my bed because I'm doing this on my bed. Okay. Is he doing this in bed? Respect is so unprofessional. Okay. Let's solve this. You have to solve for one of the variables. You have a few choices here, right? This 3R, you could divide by 3 and get that R all by itself, but that's 20/3 and negative 5Q over 3. I kind of messed that up. I was trying to blow a raspberry. No, bad. Don't do this, okay? I mean, you can. You're welcome to. But oh my goodness, look at that R. That R is nice and perfect right there. If I just subtracted 2Q, that would be gone. So let's do that. I say R plus 2Q equals 9. I will subtract 2Q from both sides, and I get R equals 9 minus 2Q. Now let us substitute that in. We're going to take this and substitute it for R. Okay, so R equals this. And I'm going to substitute that here in that place of that 3R. So 20 minus, was it 5Q? 5Q equals 3R. And so R, I'm just going to replace, substitute. So R is 3 times 9 minus 2Q. Let us distribute. 3 times 9 is 27 minus 6Q. Let us add 6Q to the other side and subtract 20 from both sides, lending me Q equals 7. Hooray! Now I just need to find R. But if you notice, boop, boop, right? R equals 9 minus 2 times Q, where Q is 7. So therefore R equals 9 minus 2 times 7. Therefore R equals 9 minus 14. So R equals -5. I think that's right. -5. And so my answers are -5, comma, well, I guess we don't really write it like that because it's R and Q, huh? So let's just write it like this. R equals -5 and Q equals 7. Hooray! Fantastic. That's not a rectangle. Okay. Goodness, I got the sniffles. Hate it. All right, next one. I've got substitution yet again. So let's do this. I've got 9a, 6b, -2a, 8b. Look, when you take a look at these and you choose just something to solve for, think a few steps ahead. All right, think ahead. Don't just pick something at random. Think what's going to be easiest to solve for, right? And you can think about this by looking at your coefficients on A and B. Look at this coefficient of 9 on A. That means to solve for A, I will eventually have to divide by 9. Is 15 over 9 very pretty? It is okay, but it's not quite the prettiest, right? But same goes for 6. 15 over 6, not the most beautiful fella in the world, right? But what if I look at -2a? If you divide that by -2, you'll divide this by 2, this by 2. Hey, those are even numbers. Those divide evenly, meaning I avoid fractions. So it seems like the bottom A is the best one to use. So let's do that. -2a plus 8b equals 2. So let's solve for A by subtracting 8b. You get 2 minus 8b, and I divide by -2. So divide by -2, divide by -2, divide by -2. Yikes. Yuck. Divide by -2. Okay. So I get A equals 2 divided by -2 is -1. Double negative is positive, and 8 divided by 2 is 4 times B. So there's A, and I'm now going to plug this in for A. So this is where it starts to get a little more complicated, all right? A little more dicey. This fella, we're going to put right here, and that A right there. So let's do that. 9A minus 6B equals 15. So I say 9 times -1 plus 4B minus 6B equals 15. I have to be really careful with my 6's and B's because they look a little similar. 9 times -1 is -9 plus 36B minus 6B equals 15. Let us add 9 to both sides. And their 36B minus 6B is 30B equals 15 plus 9 is 24. So B, we got to divide by 30 here, meaning B equals 24 over 30. But you should be able to simplify that, right? Let's try this. What are those both divisible by? 4, 6? I don't know. I'm thinking here. How about 3? Just real quick. Divide it by 3 over 3. You get 8 over 10. Oh, okay. Divide that by 2 over 2. You get 4/5. All right. So let's change colors here. Okay. So 4/5. woo, up here. And we're going to use this. It goes, woo. So b equals 4/5. Then a equals -1 plus 4b. So a equals -1 plus 4 times 4/5. So a equals -1 plus, that's 4 times 4 is 16 over 5. So a equals -1 plus 16 over 5. That's like -5 over 5 plus 16 over 5. Which means a equals 11/5. Done. Finished. Hurrah. Huzzah. So, final answer, A is 11/5 and B is 4/5. Okay? And there you go. Are they a little ugly? Sure. I guess so. But, I mean, that's not the worst. You know, like, they're fifths, right? Fifths aren't the worst fraction. It's not like I'm doing, divided by 17 or something, right? Those aren't that bad. Oh, my goodness. Oh, my gosh. Oh. I'm so sorry you had to witness that. I wish I could edit that out, but I'm not an editor, and I don't have time. So you'll just have to bear with my ugly, disgusting coughs. I apologize. I promise you, I'm not contagious over the web. I think what's getting a lot of you guys right now is this fraction manipulation stuff. Well, that's kind of like, I don't know, 6th, 7th, 8th grade math. So if you need to review that, I can send you some IXLs where you can practice that skill. But it's kind of assumed that you know how to do that by now, considering where you are. So it's okay. I mean, fractions used to get me a lot too. You only get better with them once you work with them. If you avoid them at all costs, well, you're not going to get good with them. Okay, number 4, and this one's interesting. I like this one because this one asks, does it have 1 solution, 2 solutions, no solutions, or infinite solutions? This one's kind of cool. So let's use substitution here. I'm going to solve for one of my variables. It does not matter what I pick, and in all honesty, there's not really a best choice here. I mean, you got 2/5 x, you got 1/2 y, you got 4x, you got this y. I mean, I don't know. It's kind of your choice what you do. So what I'm going to do is, let's just solve for x here. Let's just solve for this first x. It's arbitrary. It doesn't matter, right? I can pick that. So let's solve for x. So I got 2/5 x equals 10 plus 1/2 y. How do you do this? Well, we talked about this pretty early on in the semester, and some of you knew this, some of you didn't. But to get rid of that 2/5 as a coefficient on x, you multiply by the reciprocal. And the reciprocal of 2/5 is 5/2. So I'm going to do 5/2 times 2/5 x, because this cancels out the 5s, it cancels out the 2s. And then I got 10 plus my 1/2 y, where I'm going to multiply that by 5/2. So let's do that. I get x equals 5/2 times 10. Well, 10 times 5 is 50, right? Here, look. Let me distribute it for you so you can see it. So you can see what I'm doing and not just say it out loud. 10 times 5/2, well, 10 times 5 is 50. 50 divided by 2 is 25. And then 1/2 times 5/2 is 5/4 times y. Okay. Now, if you put this back in for x, man, I used too much space here. Ugh. Let's put this in for x. I've got 4x equals 100 plus 5y. Let me change colors here. Bloop. Bloop. 4x equals 100 plus 5y. we're going to, where's my highlighter? Substitute this x with this x. So 4 times 25 plus 5/4 y equals 100 plus 5y. Let's just move this up here. 4 times 25 is 100. And 4 times 4 times 5/4 is 5. So this is plus 5y equals 100 plus 5y. Okay. So what's happened here is you've got this statement. Now look, you could subtract 5y from both sides if you wanted. I don't care. You say 100 equals 100. Yeah, that's true. Yeah, that's true. And so I didn't really tell you this because I was hoping you'd remember it from Algebra 1, but it's all right. If you didn't, it's fine. Whenever you get something like this where you get a true statement, but you haven't really solved for a variable, that indicates it is infinite solutions. All right? A 100 equals 100 is a true fact. We basically did math with x and y, and we found a statement that's true, meaning whatever x or y you choose, it doesn't matter. Whatever x or y you choose, you're going to get this 100 equals 100 statement, meaning there are infinite solutions to the system. Okay? Now, I don't think it necessarily means there's infinite, like you can pick any x and any y, but it just means that those pairs of x, y's, there's an infinite number of possibilities to choose for that solution. Okay? And that's a little hard to wrap your brain around at first. When I say infinite solutions, I don't necessarily mean any number works. I just mean that there are infinite pairings, x and y, right? There's just an infinite number of these that will satisfy this equation. Okay? All right. Let's move on to number 5. Now this one, this one I think has been giving you guys the most trouble, which is understandable. All right, it's understandable. That's why I threw it on here, to give you something to chew on. I say, Mr. Spake, why are you making my life so miserable? I say, you're going to thank me. I think you will thank me in calculus when you have to do this on the reg, meaning normally you just got to do this all the time in calculus, like without fail. Like, oh my gosh, fractions are everywhere in calculus and completely unavoidable in calculus. So yeah, you got to get good with fractions, okay? Okay, so what's our goal here? I noticed many of you solved for A in terms of B and C. Where's my little laser pointer? I noticed you solved for A using this first equation. What was your idea with that, right? I mean, if you did that, you get A equals, what is that, -3 minus 3B minus C over 2. What are you going to do with that, right? That's disgusting. What are you doing, right? Do you have an A to substitute? There's no A here. There's nothing to substitute. Don't do that, right? Blech. Okay, so let's do something else, right? Let's solve for a different variable. Now, let's use this bottom equation because really, if you're viewing this, look, you've got B and you've got C. I'm going to hold this for a second so you can see it. You got B and you got C. This is a 2 by 2. You can solve this 2 by 2 using regular old substitution. Worry about this third equation once you found what B and C are. Okay? So pick a B or pick a C. It does not matter. I'm going to choose to solve for B. Okay? So B over 3 plus C over 2 equals 1. I will subtract c over 2 to the other side. And then to get b alone, I will multiply by 3. b equals 3 times 1 minus 3 times c over 2. 3c over 2. Okay? And then we will substitute that into the other equation, being this guy. So this b gets substituted into that b. Okay, we'll switch colors here. So 2b plus 5c equals 14. b is, so just 2 times 3 minus 3c over 2 plus 5c equals 14. I multiply this out, say 2 times 3 is 6, minus 2 times 3 is, 3c, and then plus 5c equals 14. Negative 3c plus 5c is 2c, so this is 6 plus 2c equals 14. Subtract 6 from both sides, 2c equals 8. Therefore, c equals 4. And now that c equals 4, let's do green. So whoop, b equals 3 minus 3c over 2. So b equals 3 minus 3 times 4 over 2, which means b equals 3 minus 12 over 2, which means b equals 3 minus 6, which means b equals negative 3. Okay, so I got my b, I got my c, but I need to find a still, right? So let's switch to another color. 2a plus 3b plus c equals negative 3. This we're going to use up here, and this we're going to use up there. So let's replace, let's see, 2a plus 3 times negative 3, and then plus 4 equals negative 3. Okay? Come on, iPad. So this is 2a, let's see, minus 9 plus 4 equals negative 3. There's 2a minus 5 equals negative 3. Add 5 to the other side, so 2a equals 2. Therefore, a equals 1. Okay? So my answers are a equals 1, b equals negative 3, and c equals 4. Is that what I got on my computer? I'm going to double check my answer here. That one is a little long. A little long. Let's see here. Am I correct? Yay, I am. I'm good. Box. Hooray. Yeah, it's ugly. That's about as ugly as it got, though. And yes, you had fractions, but I creatively planned this so that the fractions will cancel, and so you're not stuck with them. Okay? You only had to deal with fractions for a minor minute, right? You dealt with them here, you dealt with them here, you dealt with them here. But at this point, it cancels. There's no more fractions after that point. And then there's like no fractions pretty much anywhere else. I mean, okay, maybe here, but that's a whole number, so, right? You really didn't. Some of you are really overcomplicating this. Be mindful with your choices. Try to pick something that's going to be easy, and that does require forward thinking, and it does require practice. You'll get there. It just takes practice. Okay. Okay. So let's move on now to questions that involve elimination. This first one is, easy. Sorry. I shouldn't say that. It's bad for your teachers to say something's easy, because it is. It's bad practice, okay? It's not easy. But comparatively, this is much easier to what other problems we've been doing. We want to use elimination on this, which means pick a variable and eliminate it. Meaning, Add variables together. Pick equations, add them, and eliminate one of your variables. Well, if I multiply the first one by -1, watch what happens. I get negative 4w plus 5r equals positive 11. Let us add that. I get negative w. Those cross out. Equals, what is that, 4? So therefore, w equals negative 4. Okay. And now plug this in. All right? Pick an equation. It doesn't really matter what you pick. Plug in w equals negative 4. Let's just pick the top equation just because. Seriously, it doesn't matter. W is negative 4, so 3 times negative 4 minus 5r equals negative 7. So that's negative 12 minus 5r equals negative 7. Add 12 to both sides, negative 5r equals 5. Divide both sides by negative 5r equals negative 1. Okay? So I like to do my answers in gold. Let's do w. W equals negative 4, and r equals negative 1. That is a really, really basic elimination problem that you can hand an Algebra 1 student and they should be able to solve. Like, that would be on a STAR test, all right? Because it's just right there. In fact, I think that's too easy for STAR. That would be an easy question on a STAR exam. This is more like what the STAR exam might look like. But that's Algebra 1, right? That's not really Algebra 2. Okay, so let's see. How do we do this? We have to use elimination here. How do we go about doing this? Well, pick a letter. Does not matter which. To solve for, to eliminate, right? Pick a letter to eliminate. So you have a few choices here. You've got this 5a, 2b, 3a, 5b, right? Do some forward thinking here. Here's this negative 5 thirds. If you multiply this by 3, that will get rid of that third, right? And just be negative 5. So if you have 3a and you have 5a, you could multiply the top equation by 3 and the bottom equation by 5 to make this 15 and 15, right? Because 5 times 3 equals 15 and 3 times 5 equals 15. So why don't we do that? All right. We're going to, let's say, multiply by, what do you want to do? Just 3? Okay, sure. And then this one we will multiply by negative 5. So the top equation becomes 15a plus 3 times 2b is 6b equals negative 5. And the bottom equation multiplied by negative 5 is negative 15a minus 25b equals positive 5. Add these are gone. Get negative 19b equals 0. Divide both sides by negative 19. And so b equals 0. Okay? And get b equals 0. By the way, some of you, and I don't know where this is coming from, some of you, when you get like x equals 0 or y equals 0, you're saying no solution? What do you mean? Huh? What? Hello? I don't know why you're saying that. Your answer can be 0, okay? I'm not sure where that thought process is coming from, but I just kind of want to address in this video. Your answer can be 0, okay? That's fine. Look, negative 19 times 0 is 0. Boom. That's true. So b equals 0 makes that true, okay? From here, let's just plug something in. So I got 3a plus 5b equals negative 1. We're going to substitute this b equals 0 here. So 3a plus 5 times 0 equals negative 1. That just means 3a equals negative 1, meaning a equals negative 1/3. A equals negative 1/3. All right? I don't really like how that line looks. I'm going to rewrite that line. 3a plus 5b. There you go. So my solutions are a equals negative 1/3, b equals 0. Boop. No, that's ugly. Hideous. Let's try that. There we go. Pretty. All right, we're getting there. Just a few more. Number 8. Let's try this. So yeah, the ones, they're coming a little bit more complicated now, but if you know what you're doing, you're fine. If you don't know what you're doing, you're probably lost. And that's okay. That's why I'm making this video. So, we're kind of jumping into 3x3s now, which is 3 equations, 3 variables, or 3 unknowns, because you have y, z, and x, right? You have 3 of them. But I want you to notice here that this bottom equation, this is a 2x2 system with x and y, or x and z, I mean. So eliminate one. It doesn't matter, okay? I'm going to rewrite those 2 equations. 2x minus z equals negative 1. I just subtracted this z over, okay? That's what I did. I subtracted that z over. And this is x plus 1/2 z equals 1, okay? I know I can match this, so I could probably cancel out the x's if I multiplied by negative 2. So let us multiply by negative 2. Here, I don't like that x. It's too confusing. Let's say dot. Multiply by negative 2. I get 2x minus z equals negative 1. Negative 2x plus... Ooh, sorry. It's going to... I'm sorry. Stupid sniffing. I hate it. I can't speak full sentences. Negative 2 times 1/2 is negative 1. So this is minus z equals negative 2. And I will add this. By the way, there is a line here. Ugh. Line. So these are gone, and I get negative 2z equals negative 3. So therefore, z equals negative 3 over negative 2. A double negative is a positive. So this is positive 3/2. Okay? So, yeah. This one's got a bit of an ugly z, but we'll get through it. Okay, we'll get through it. Now, let's plug that in. So, 2x minus z equals negative 1. I'm picking that from up here. Okay, you could pick either one. It doesn't matter. You can pick this fella, or you can pick this fella. Just pick one. It's not a big deal. And just substitute z with 3/2. So you get 2x minus 3/2 equals negative 1. Add 3/2 to both sides. Say 2x equals 1/2. And then to divide both sides by 2, do you know what 1/2 divided by 2 is? 1/2 divided by 2. Anytime you divide a fraction by another number, you just multiply those denominators. 2 times 2 is 4. So x equals 1/4. And z equals 3/2. And now that I have those, I'll sub this in. Let's do green. Phew. Sub this into y plus 3z equals 2x plus 3. I want to make that a little bit prettier. equals 2x plus 3. So y plus z is 3. Okay, so this is 3 times 3 halves equals 2 times 1/4 plus 3. So you get y plus 9 halves equals 2 times 4 is 2/4, which is 1/2 plus 3. So let's subtract 9 halves from both sides. I get y equals 1/2 minus 9 halves is negative 8 halves plus 3. But negative 8 halves is just negative 4 plus 3, so y equals negative 1. And that is correct. Those are the answers. Yes. So my answers, or I guess in this case, you can just write it as an ordered triplet. X is 1/4, y is negative 1, and z is 3 halves. Now, were the answers a tad bit ugly on this one? Yes, they were. But they're not the worst fractions, okay? They're really not. And you got to get comfortable with dealing with those. You have to. They're not going to go away. Okay, so that's 8. Let's move on. Ooh, 9. Okay. Now, this one, 9 and 10, is where this starts to get legitimately difficult, okay? We have to use elimination multiple times to solve for something. Now, the difficulty of number 9 is you have a 3 by 3, but it's M N P, and then it's MP, and then it's NP. So in the previous problem, we had a 2 by 2 system, and we just solved that 2 by 2 system first with elimination, and then we just use substitution on the third equation in top. Number 9 is where this gets a little more tricky because this is not a 2 by 2 system. This is 2 equations with 3 unknowns, right? That's what that is. So what we need, let's see, what we need. We need a 2 by 2 system. So pick 2 variables for this system. Now, it doesn't matter which 2 you pick. You can pick M and P, N and P, or M and M, M and M, M and M. You can choose that. Doesn't matter. I don't know. What do you think? You just look at it. What do you think? Think about it for a second. I'm going to stretch my leg while you think, or while you click fast forward on the video. So let's get a system. Let's try this here. Let's choose. I don't know, N and P. How's that? Do you like that? Do you like M and P? Sure. Okay. N and P. So let's choose N and P. I need N, P, N, P. That's what I need. This is what I need. This is what I need. Now, if I highlight this, this equation, I want to do that in yellow. This equation can be put here. So the question is, I need to create this one, okay? I must create this equation using elimination. And really it's quite simple because if you look up here with these 2 equations, they both have P in them and they both have M in them, but only one has N. I need N and P. So I need that p to stay there, and I need that n to stay there, which means the m's must cancel. That's the goal. Must cancel out the m's. So eliminate m from equation, or I should say using equations 1 and 2. So let's do that. 3m minus n equals negative 2p minus 5, and m plus 3p equals 10. This takes longer to explain than it really takes to do. Let's rearrange that. So it's 3m minus n plus 2p equals negative 5. And then it's m plus 3p equals 10. But I want that, I want to cancel the m's, right? So let's multiply by negative 3. That way I get negative 3m, right, to cancel that out. So this way I get 3m minus n plus 2p equals negative 5. And on bottom I get negative 3m minus 9p equals negative 30. Add those. Canceled. I get negative 2. What is that? Minus 7p equals negative 35. All right. So this equation goes up there. That's what you want. All right? That equation goes up there. So I'm going to say, see next page. What does your 2x2 system look like? Well, oops, let's add a page. Stop. Oh my gosh. Add. Hello? Add. Okay, cool. So I need my 2x2. So let's go to blue. I need the first one, right? This was this NP idea, where this one was highlighted in green and this one was highlighted in yellow from the previous question, right? So I had, laser pointer, 2n plus 4p equals 20. 2n plus 4p equals 20. 2n plus 4p equals 20. And the green, I had negative n minus 7p equals negative 35. Negative n minus 7p equals negative 35. So now you have a 2x2 that you can eliminate n from. So I'm going to have 2n plus 4p equals 20. I'm going to double the bottom, so it's negative 2n minus 14p equals negative 70. And we'll add these, so these cancel, and this is negative 10p equals negative 50. Divide both sides by negative 10, so that p equals 5. And then from here, bloop, 2n plus 4p equals 20, right? But p equals 5, so 2n plus 4 times 5 equals 20. So 2n plus 20 equals 20. Subtract 20 from both sides, so 2n equals 0. Divide both sides by 2, so n equals 0. Boom. I don't like that p, so I'm going to do that. Plus 4p. 4p. Okay. So you found n equals 0, p equals 5. Am I on the right track? I'm going to double check my answers with my key. Hello? Stop. Oh, I can't stop sniffing. My goodness. My goodness. Okay, yeah. Think I'm good so far. Now I just need to find M, right? Now, find M using, which ones? I've got equation 1 or I've got equation 2. So, using equation 1 or 2. I like equation 2. It says M plus 3P equals 10. So I'm going to use that one. M plus 3P equals 10. This is equation 2. So M plus 3 times 5 equals 10. So M plus 15 equals 10. Therefore, M equals negative 5 by subtracting 15 from both sides. So final answer, right? Final answer. No, I can't do the curly brackets. M equals negative 5. N equals 0. P equals 5. And there you go. Okay? Yeah, well, it's kind of long. It's just because it takes long to explain. And there you go. All right? There you go. There's that one. Okay, last one. And this is the hardest of them all. Let's rewrite this equation, or this system. So, to rewrite. This is a true 3 by 3 because it is all 3 equations with 3 variables in each. So we're going to rewrite this as x plus 2y plus z equals 9. Then 2x plus y minus 3z equals 0. And 3x, minus 4y minus 5z equals 1. And if you don't know how I did that, Google how to rewrite an equation in standard form, because that's all I did. Look, I got x, y, z over here, x, and then y, z need to come over here, and then this negative 1 needs to go over there. Okay? That's what I did. All right. So, same goal as number 9. Get a 2 by 2 system. Now, the way you're going to do this, I actually like this one better, is eliminate, just pick 2 pairs of equations, okay? Pick 2 pairs. Pairs meaning 2 twos, right? Pick 2 pairs of equations. Eliminate the same variable. So I'm going to pick equation 1. Look, I'm just going to go with x. And here's why. This is 1x. 1x can be easily multiplied by negative 2 to cancel out with 2. It can easily be multiplied by negative 3 to cancel out 3. It's also true you can do the same for z or y. It doesn't matter, okay? I don't care. It's whatever. So I'm going to choose to eliminate x. I choose to eliminate x. So first equation is x plus, let's do this in a different color. Let's do blue now. X plus 2y plus z equals 9. And then I have 2x plus y minus 3z equals 0. If I multiply by negative 2 on the top equation, I get negative 2x minus 4y minus 2z equals negative 18. On the bottom, I get 2x plus y minus 3z equals 0. I will add these, so x's cancel. I get negative 3y minus 5z equals negative 18. Okay? So all I did, I set up I picked a pair. I just picked the easiest pair and eliminated x from one of them. This got me an equation with y and z. 1y, 1z. Now I just want to do that again with a different pair. So pick a different pair. Okay? So this is pair 1. And then this is going to be pair 2. All right? X plus 2y plus z equals 9. And I'm going to use equation 3. So notice what I'm doing. I'm using equation 1 again, but now I'm using equation 3, and I'm going to eliminate x by multiplying by negative 3. So copy this 3x minus 4y minus 5z equals 1. Let's multiply on top by negative 3. So I get negative 3x minus 6y minus 3z equals negative 27. And then 3x on bottom minus 4y minus 5z equals 1. Add. This will cancel. I'll get negative 10y minus 8z equals negative 26. Okay? Okay. So these are now your two, what do you call them? Hello? Where's my highlighter? There he is. There's your first equation. There's your second equation. This is your 2 by 2. You now have your 2 by 2. I'm going to switch to green. So negative 3y, I'm going to circle it. Negative 3y minus 5z equals negative 18. And negative 10y minus 8z equals negative 26. Okay? Boop. Now I need to get these to match. And I'll admit, this part's kind of ugly. I actually preferred the first two steps over doing this next one. It's kind of hideous, but we'll do it. Let's eliminate y. Let's eliminate y. So I'm going to multiply the top equation by 10. And I'll multiply the bottom equation by negative 3. That way, negative 3 times 10 is negative 30. And negative 10 times negative 3 is positive 30. So I have negative 30 and positive 30, and I add those, they will cancel. Okay, that's my idea. That's my thought process. So negative 30y minus 50z equals negative 180. And then on the bottom, I get 30y plus 24z equals, I don't know what 26 times 3 is. I don't want to do that. No, my head. I'll just use a calculator. 26 times 3. It's too late for this. 78? Okay. So this is positive 78. Add this, cancels. Negative 50 plus 24 is negative 26z equals negative 102. So divide both sides by 26. Negative 26, 102 divided by 26. Negative 26. I get z equals negative 17. Like so. All right. Oh, not negative, though. Not negative. I'm going to say, therefore, z equals positive 17. Okay? From here, you can figure out x and y just using normal substitution. Okay? I'll do it just to finish it off. Use sub to find x and y. on the next page. Okay? So notice how negative 3y minus 5z equals negative 18. I'm going to copy that. Boop. Negative 3y minus 5z equals negative 18. Earlier result. That's what that is. And I figured out that z was 17. Plug in z equals 17. So negative 3y minus 5 times 17 equals negative 18. Hey, I want to make sure that this is right. Ugh. My wrist is hurting. Uh-oh. Uh-oh, no. Hey, hold up. That's not correct. Oh, yikes. Okay, I just checked my answer key real quick because I didn't want to go further. That didn't seem right to me. What happened? Hold on. I'm not going to restart the whole video just for this silly mistake at the very end. See, even Mr. Spake makes mistakes. Even Mr. Spake makes mistakes. Did I copy the problem down correctly? Because that was the number one thing that got me as a student. It still gets me today. Is just copying down the problem wrong. But no, that's good. Oh, I see it. Oh my God, I see it. No. Do you see it? Do you see where I went wrong? Maybe you saw it at the very beginning of the video. It's this stupid negative 3z. Grrr. Well, see? This is the kind of frustration you have to learn how to deal with. That's a plus. If you saw that mistake and watched me work this whole thing out, you are probably so upset. And I apologize. But I'll change this to plus 3. This is plus 3. Which makes this negative 2z plus 3z is plus z. Okay. And I'll still leave that highlighted. Bloop. And sorry, I'm making fixes here. Oh, see how I did. And this is what I mean by showing your work. If I caught your mistake right there, but you did all of this correctly, I'd basically give you full credit. Because do you see how easy of a mistake that is to make? It's so easy. It's so easy to make that mistake. Even Mr. Spake makes it. You got to be really careful. I mean, you do. All right? You got to be careful. But it was only here. So it fixes this. It's not a part of this. So all that works fine. All that changes is that this negative 5 is now a positive z. Yeah. So this negative 5 is now plus z. Okay. But all these steps are the same. All that's different is this negative 50 is actually positive 10z, which makes this not negative 26, but rather 34z. And so we'll just fix that. Divide by 34, divide by 34. So now I'm doing 102 divided by 34. Okay. Negative 102 divided by 34. I get z equals negative 3. Cool. Okay. Now, it's really unfortunate I made this mistake during the video, but that's okay. It happens. And notice, all of my math was fine. I messed up in the rewrite step. The rewrite step. The first darn step. Be careful, guys. Now I'm glad I made this mistake, so you can see firsthand just how easy it is to make. Okay. So this is all the same, but instead of 17, I'm plugging in -3. Oops, I want to make that red. So plugging in z equals -3. So this is bloop, -3. This is -3y plus 15 equals -18. So -3y equals what is 18 and 15? 33. Hold on. Oh, hold up. That was changed, wasn't it? Yeah. That was changed. Look. That's not the same. We changed that. That was now -3y plus z equals -18. -3y plus z equals -18. This was an earlier result. Now we're going to plug in z equals -3. Okay? -3y minus 3 equals -18. So -3y equals -15. Therefore, y equals positive 5. And now we can substitute z equals -3, y equals 5. We're going to sub this into any equation of our choosing. I'll choose the top equation. X plus 2y plus z equals 9. And we will just sub those in. Z is -3. Okay, so x plus 2 times 5 minus 3 equals 9. X plus 2 times 5 is 10. 10 minus 3 is 7. So subtract 7 from both sides. X equals 2. So final answer, x is 2, y is 5, z is -3. And that's our box. Like so. Hooray! There it is. Oh my gosh. All that beautiful work. Look at what we all did. Okay. There you go. That's a homework solutions guide. Yeah, that last one's pretty ugly. But I mean, I'm not throwing you that on the test, so you'll be fine. I could, though. We had it on last year's test. We did. But I don't think we're going to throw that on this year's test. It's just a lot. And if you make a tiny mistake like I did earlier, it kind of gets you all jumbled up, right? All jumbled up. But you might see something like number 9. You got to know how to do something like number 9, okay? You got to. Okay. So I hope you found this homework video helpful. I don't even know how long I've been talking. I don't know if this has been an hour or an hour and a half or what. But I hope you have found this helpful because a lot of you don't have time for Raider time in the morning or whatever. So, all right. Take care, and I'll see you in class.